ionic and covalent bonds. All right. A compound is when two or more things on the periodic table bond together. All right. Ionic is whenever let me draw my little stair-steppy line here. Ionic is when you take a metal, something on the left-hand side of the periodic table, and bond it with a non-metal, something over here on the right-hand side of the periodic table. They transfer electrons. All right, so like over here, I've got sodium and chlorine. Sodium's over here on the left-hand side. Chlorine is over here on the right-hand side, and they will actually mail the electron over to the other one. What happened is chlorine has got 7 electrons, or valence electrons. It wants to get to 8. And then sodium's got 1. And so it's much easier for chlorine to go and steal 1 electron from somebody than it is to try to give up all these 7. And conversely, sodium, it's easier for it to give up its 1 than it is to go and find 7 more. All of them want to get to 8. They all want to have that magic number, that octet number. And so sodium wants to give away 1, chlorine wants to gain 1, and so they go good together, where sodium will give up its electron and it'll sit over here in chlorine. And then this outer ring will disappear from sodium, and the inner ring is already full, and so it's all nice and happy as well. And so with all of these, the metals will always give up their electrons. The non-metals will always steal the electrons or receive the electrons whenever it gets transferred over. Covalent bonds don't do that. They share electrons. They don't mail over the electrons. And I always say, and that will be if a non-metal and a non-metal get together. You know, they're both over here with the and the non-metal side. They're right over here together. They're close enough they can share it with each other on the periodic table. They don't have to mail over or transfer that electron. The only oddball with that is hydrogen. Hydrogen is over here with the non-metal group. Anytime anything bonds with hydrogen, it will be a covalent bond. Covalent bonds, if I look at carbon here, carbon has the blue dots where we have 4 valence electrons. You know, carbon will be sitting right here, and it would have 1, 2, 3, 4 valence electrons. It wants 8, so it bonds with hydrogen, and hydrogen brings in its 1 on each side. Now carbon has the 8 that it wants, but carbon's also sharing its 1 electron with the hydrogen, because now hydrogen has 2. Okay, just remember that they all want 8 except for, remember, hydrogen and helium are the oddballs. They only need to have 2 to be like helium, because helium only has 2 valence electrons. So everybody is happy here. These electrons will sometimes be spinning around carbon. Every now and then they'll spin around the hydrogen, and they just share those electrons, and everybody stays happy. So ionic bonds are transfer. They are a metal on the left-hand side with a non-metal on the right-hand side. Covalent bonds share electrons, and then we have 2 non-metals over here together on the right-hand side of the periodic table.